Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through the introduction to vector algebra. In our previous lessons, we've gone through complex numbers, we've gone through several other subtopics under algebra. So we continue with vector algebra. Please, if this is the first time you are being with us on this channel, kindly subscribe to support and also share to your friends as well. So vector algebra. As an introductory course, I'm going to take you through the fundamentals. What do we mean by vector? So when I say a vector quantity, what do I mean? So a vector. So a vector is simply any quantity, okay, is a quantity which has got what you call magnitude. How much? Then we have another dimension, what you call direction. Okay. I have a Cartesian coordinate y and x. I have my origin O, right? If I locate any point in this space, right? Let's say point A given as 1 1 1, okay. Now point A is simply a point within the Cartesian plane. If I want to make this point A quantity called a vector quantity, what do? I need to define its magnitude with respect to a reference, as well as I need to define its direction from a point of reference. Within the Cartesian plane, the easiest point of reference, or the general, or I would say the fundamental point of reference, is the what? Is the origin. So if I'm able to draw a line connecting the origin to this point, then I can define the direction of this point in space so that anytime I give you this direction, you can reproduce this point as it is. Same thing, right? So you realize that the distance from my origin to the point A is what we call the magnitude. It's what we call the magnitude m. Magnitude. Okay? So that's the distance. And look at the direction. Look at where it is pointing to. It gives us the direction of what's this point. Therefore, I can call this vector OA with this direction. So this is simply what we call a vector. Okay? So a vector is simply any quantity which has got magnitude and direction. So we have notations in algebra. How do you see that a particular expression given to you is a vector quantity? So the general one is what I showed you, OA. It has a bar on it nicely. Okay. Sometimes they wouldn't say anything. They will just write A is equal to, and they'll open this type of bracket. It's angle. Okay. Look at how it is. They'll give you A1, A2, A3. This is what we call a three-dimensional vector. Okay, we have two-dimensional, four-dimensional. So depending on the number of um columns you can get, you can equally make this a this one is a row form, so it has got three columns, right? We can equally make it A1, A2, A3. Okay, right? Then you make it A. So with this one, you can put a small bar. That was also another representation. You have something small, so A, then I'll put a small dwindle on it, is equal to this. This becomes what? A three-dimensional vector, as simple as that. Okay, so one key thing when you are doing vectors is how to express coordinates into vector quantities. It's similar to what we just did, right? So let's take a problem for you to understand that. So the problem is the problem says that, so example 1, find the vector represented by the directed line segment with initial point A given as 2, -3, 4 and terminal point B given as -2, 1, 1. So it says find the vector represented by the directed line segment with an initial point A and terminal point B. From the previous example that I showed you, we realized that our initial point was the origin and we ended at A. So every vector happens to have this feature like a line segment. It has an initial point, it has an ending point, okay? And the direction is indicated on this line segment. The magnitude of the vector is simply the distance covered by this line. As simple as that. Let's solve this problem and how to do that. Anytime you are given two coordinates for you to find vector out of it, we are trying to say that make one coordinate the terminal vector and make one the initial vector. So let's see how we solve this problem. What do? We need vector AB because the terminal is B and the its initial is A. So anytime you want to find vector AB, this is what you do. Let me represent this on the diagram and you will understand it well. So let's say this. Now this is three-dimensional, right? So meaning we have X, Y, Z, right? Let's say I have point A here and I have point B here, okay? So I just want the line connecting these two. But for me to find it, I will reference it to the origin O here, okay? So I'll create this and I'll create this. Where from here to here is OA and from here to here is what? OB. And this is just an idea of what you call the parallelogram law, or half of it, which is the triangle law of vectors, okay? So that for me to add any two vectors, I simply have to find the terminal and the initial point of one and the other. Then I'll also what? Put it together. So right now, since I want to find A to B, I will simply have to what? Move the reverse direction, right? So it's simply from here to what? To here, right? So from here to here, then it will come here. Because of that, if I'm moving in this direction with this as positive, right? Let's say let me say this way. So these are the two current one. Let me make it here. So we have this one are the original ones that we have, and you are trying to cross it, okay? So generally we say that to find vector AB is simply vector OB minus vector OA, as simple as that, okay? So what do? My OB, you bring out the coordinates -2 1 1 minus OA, which is 2 -3 4, right? So once you have this done, what is -2 minus 2? It's -4. You write -4. 1 minus -3, that is +4. 1 minus 4, -3. Therefore, my vector AB is simply equal to -4, 4, -3. As simple as that, okay? Now, one thing you also have to know in vectors is what you call the distance. How do you find the distance? Okay, so the distance or modulus of a vector is simply represented with two bars. If I put vector AB here, what I'm trying to say is that find the magnitude of vector AB. They may not say that find the magnitude, they may not say that find the distance, but once you see that you have this, it means that find the magnitude. The formula is very simple. If you have a general vector A, which is a two-dimensional vector A1, A2, to find the distance A like this is simply equal to the square root of A1 squared plus A2 squared. As simple as that. If you have A, which is a three-dimensional vector, A1, A2, A3, then the magnitude of A is simply the square root of A1 squared plus A2 squared plus A3 squared. As simple as that. So you simply have to do this. It's not difficult, right? Now let's solve some few set of problems here. So example 2, if I have a vector A given as 4 0 3 and a vector B given as -2 1 5, find the magnitude of A and the vectors. I have the first vector to be A plus B, A minus B, 3B, then 2A plus 5. So let's go through this problem for you to understand some few concepts here. So the first problem says you should find the magnitude of A. So you find the magnitude of A is square root of what? Each term in it. So I have 4 squared plus 0 squared plus 3 squared. And I'm going to have square root of 16 plus 9, because this is 3 squared, this is 4 squared. This only give me square root of 25, and that is equal to 5. and choose to just write 5. Okay, so this is the first one. Now the second one says we should find a plus b. So in vectors, you can add vectors, you cannot subtract vectors, but there is one rule: components should subtract or add component, corresponding component. You cannot add two-dimensional vector to a three-dimensional vector. It's not possible because we don't have corresponding component. Let's say this: I have a1, a2, and I'm adding this to b1, b2, b3. What are you doing? You can't do that because a1 will have a component, a2 will have a component. There is no component for a2, so it's an error. Okay, so we simply add the vectors of the same dimensions, or equal dimensions. That is all. So here, let me find a plus b. A and b, you can see they are all three-dimensional vectors, right? So I'll simply have my a plus b given as 403 plus negative 215, and that is giving me what? 4 plus minus 2 is 2, 0 plus 1 is 1, then I have 3 plus 5 is what? 8, right? Therefore that is giving me 218, as simple as that. Then the c is a minus b, right? So it's almost the same. 0 0 403 minus my b negative 215, right? This gives me 4 minus 2, which is 6. 3 0 minus 1, which is negative 1. 3 minus 5, which is negative 2. That gives me 6 minus 1 minus 2. As simple as that. Then you have 3b. 3b. This is multiplying a scalar by a vector. Okay, so 3b is simply equal to 3 multiplying negative 215. Whenever you are multiplying a scalar by a vector, simply multiply it by all the components. That is all. We are trying to multiply the component by 3. Each component, don't multiply by only one. Okay, that's an error. So this simply gives us negative 6, 3, then 15. As beautiful as that, right? So next 6, 3, then 15 as our answer. Finally, 2a plus 5. 2a plus 5, right? So that one is equal to 2 times my a, which is 403 plus 5, right? Where is it? Okay, so 2a here plus 5, right? Good. So let's break this one down here. I think it's 2a plus 5b, sorry. 2a plus 5b. Good. So I'll have 2 multiplying 463, right? 403, sorry, plus 5 multiplying b, and the b is negative 215. You first multiply your scalar before you add, okay, all the time. So 2 times 4 is 8, 2 times 0 is 0, and 2 times 3 is 6. Plus 5 times negative 2 is negative 10, 5 times 1 is 5, 5 times 5 is 25, okay. This gives me 8 minus 10, which is negative 2, 0 plus 5, which is 5, 6 plus 25, which is 31. As simple as that. So yes, these are fundamental stuff you have to know in algebra, vector algebra for short. Let's look at a few properties of vectors, then we make it for this lesson. Now, looking at the properties of vectors, vectors actually follow the same basic algebraic properties, right? So commutativity, a plus b is simply equal to b plus a, as simple as that. Then you also have associativity, a plus b plus c is equal to a plus b, also plus c. It still holds. Also, a vector plus its inverse is equal to 0. Then c plus a plus b, distributive, ca plus cb. It follows the same basic rules. So that is all I have for you in this lesson. I'll see you in the next lesson as we talk about the standard basis vectors, then also unit vectors.